Swayam Prabha. Digital India. Educated India.
Welcome back. So, we have been discussing in the last few sessions about the Bitcoin blockchain consensus mechanism, and we have seen that consensus in Bitcoin is actually a heuristic method. It uses incentives for miners to behave properly according to rules. It also uses the flexible deadline for achieving consensus, which basically leads to an eventual consistency of the blockchain on all its replicas. It also allows you to thwart any Sybil attack by making the probability of making your being the next reward winner proportional to your global hash power. And we also saw the economics that should be in the mind of the miner in terms of whether to participate in the mining process or not. When we go into the public blockchains, the private blockchains or permissioned blockchains, we will see that most of them do not have a currency associated with them. And if they do not have a currency associated with them, a currency is not mined within the blockchain, or if the currency that is mined does not have any market value, then we need another kind of consensus. We cannot depend on this kind of participatory consensus mechanism. So, but we will get to that later when we will go into the permission permission blockchain or non-public blockchain. And but for public blockchain, most of the public blockchains use some form of mining, which are some variant of this, and so let us understand it finally, putting it all together. So, there are several concepts that we have discussed. We discussed the notion of identities. In case of permission free, permissionless blockchain, what we see is that identities are not tied to real world identities. Your public key, hash of the public key is kind of your identity, and this means that I can create as many identities as I want. And many times the way the blockchain transaction rules are, you have to create multiple identities. For example, if you are paying somebody some amount and you have some left, then you have to create an alternative address that is controlled by you, to which you have to send the rest of the money, or that is called a change address. So, every time you make a new transaction, you have to create a new identity. So, everybody will have many identities. So, in a network with such kind of identity, which is not tied to a real world identity, there is a possibility of a Sybil attack, which means that somebody might create too many identities to wield more power. Let us say in a if there is a voting being done to do some computation or to do leader election and so on. So, therefore, what we have seen is that to thwart the Sybil attack, the mechanism of consensus in blockchain has built in criteria that the probability of you being the winner in case of a competition to be the maker of the next block, your probability will not depend on how many identities you have, but rather it will depend on how much resources you have. So, by creating more identities, you cannot increase your resources. So, therefore, the process is Sybil attack proof. We also saw the transactions, how the transactions are represented, and the transactions are represented by giving transaction number, inputs and outputs, and then every time you make a new transaction, you have to spend from the output of a previous transaction if that output was assigned to you. And by using your signature, you prove that you actually are the rightful or authentic owner of that output's destination, and therefore, you are allowed to use that amount. And finally, the amount should be such that the input amount should be equal to the output amount, and in case you are giving a transaction fee, the input amount should be little more than the output amount. So, therefore, not having balance will not be a problem, like as we were discussing earlier, that you have to check your balance in your account is more than your amount, transaction amount. That problem cannot happen here, because your input sum of the input should be equal to the sum of the outputs, or input should be slightly more than the outputs in case of transaction fees. We also saw that all transactions are actually broadcast to everybody, and the broadcast mechanism is through a peer to peer communication. And what it means is that so Bitcoin is an application level protocol, Bitcoin protocol, and underneath it is there is a network, and above the network, like say TCP/IP layer, you have also another layer which is the P2P layer. So, whenever you are trying to send a put a transaction into the network, you basically broadcast it to all your neighbors, and then your neighbors will broadcast it to their neighbors, and so on. And then eventually some of the nodes will actually receive same transaction from multiple different sources, because you are broadcasting it this way, and they will have to ignore the ones that they already have seen. And we will talk about that in the next series of lectures in the class, but that is the idea. So, the P2P network is one of the underlying layer of protocol on top of TCP/IP and below the Bitcoin protocol. The consensus mechanism is what we focused mostly on in this lecture, and it is very important for us, because without the consensus we cannot decide what should go into the blockchain next. And so, the block that is added at any point in time should be decided based on a consensus. But we also saw that this consensus mechanism here is not exactly like the consensus mechanism that was considered in distributed computing, like in the context of distributed databases, because there are so many impossibility results which might make you consider abandoning the idea of building a consensus protocol in a decentralized distributed environment like this. But we saw that we actually changed the model. We basically changed the model in the sense that malicious nodes, we assume, may be made to behave according to rules by giving incentives. So, therefore, the whole assumption about maliciousness that is used in the old literature is a little bit changed. Second thing that we are doing is that we are not saying that consensus should happen within each round. So, when a set of transactions, when each node accumulates enough transactions, they may propose a block, they solve the hash puzzle, and then they broadcast if they win, and then multiple people may actually win at the same time or close to each other in time, and then they might broadcast theirs also. There might be a race condition. However, eventually the race condition will be resolved, and that is what is the eventual consistency. So, we are allowing our consensus to be based on eventual consistency, which is also different from the traditional model of distributed consensus. Finally, our guarantees are probabilistic, which is that the nodes, the way they behave and their possibility of broadcasting or not broadcasting is all probabilistic. So, therefore, it is a randomized consensus, and all this thing together gives us the protocol that works in practice. And finally, the other issue, the hash puzzle we have been talking about from the very beginning, and we saw how the hash puzzle plays an important role in the mining. Miners are made to solve the hash puzzles to show their proof of work, and the proof of work we assume is actually dependent on how much computational resources you are putting in, and therefore, person who solves the hash puzzle faster has more computational resources, and therefore, the probability of them winning the competition to make the next block is proportional to the computational resources that they have. So, that is the kind of the summary of what we have been discussing. Now, few more general things about Bitcoin. So, Bitcoin actually has 3 types of consensus, and all the 3 consensus are not done through the Bitcoin protocol. So, the second one here in this list is actually called the state consensus, that is the blockchain runs the protocol, so that the state of the ledger consistent throughout all the replicas. So, that is the consensus that we try to achieve through this protocol, and that is what we discussed all along in the last few sessions. But there is also a value consensus, that is the Bitcoin's market value, right. This market value is not has nothing to do with the Bitcoin protocol, it has to do with lots of extraneous factors, such as what is the news in the market, how the investors see the Bitcoin going up and down, up or down in value, and therefore, this is also done through a distributed process. There is no central authority or bank that decides the value of the market value of the Bitcoin, but actually it is decided on by a decentralized process based on demand and supply. And then there are rules. So, we said that there are certain rules in Bitcoin, for example, how the transaction validity plays out, how the hash puzzle works out, what is the difficulty of the hash puzzle, and all these things are actually the rules, and these rules should be played along by everybody, right. So, that is another consensus, and then if a large number of nodes decide to play by a different rule, then there is something called a forking in the blockchain. So, you will see that 2 years ago there was a change in the block structure, and this is called SegWit, and because of SegWit there was actually a fork in the hard fork in the Bitcoin, and there was a block cache version of Bitcoin that forked out of the blockchain. So, we worried about the second type, that is the ledger consensus, but the other consensus are also important in the entire scheme of things. The other issue is that we want to point out is that Bitcoin is bootstrapped. Now, what do I mean by this, right? So, when the Bitcoin came into existence, very few people knew about it, only people in crypto community knew about it, and the amount of mining resources was desktops and laptops and so on, and therefore, the anybody and everybody had almost equal chance of winning the next block. And what that meant is that nobody had the ability to overpower the existing chain and create a fork or create a different chain than the legitimate consensus chain. And that has changed drastically over time as some people have put in more resources for Bitcoin mining, and therefore, the health of the mining may be deteriorating. And as we get news of the health of the mining system being worse, for example, if there is a news that China is going to nationalize all its blockchain mining companies and consolidate them, that would mean that investors will immediately panic that there might be a 51% hash power within that consolidated company, and therefore, the blockchain can be easily subverted and your old transactions may become invalid. People will take out their investment from Bitcoin, and what that would do is that the price of the Bitcoin, the value of the currency will fall. So, health of the mining ecosystem and the value of the currency are related to each other. How they are related to each other? So, we just described how the health of the mining system influences the value of the currency. On the other hand, the value of the currency also influences the health of the mining system, because if the value is very small, people will not invest in computational resources to do mining. Very few people will do mining, and therefore, there will be no competition to create the mining, and therefore, lesser mining resources there are, the chances of somebody actually among the rest of the miners becoming 51% becomes higher. So, therefore, the value of currency falls means that a lot of people will leave the mining business. The other thing is the security of the blockchain. If the security of the blockchain, which is dependent on the health of the mining system, we have been saying this, that if the mining ecosystem is not healthy, then you might see 51% attacks and maybe other kinds of attacks, and therefore, you will see that the blockchain security is compromised. Once the security compromises, the value falls, because investors will fly, because they will see that there is no value in the current, there is no security. So, anytime the Bitcoin old transactions become invalid and so on, so nobody is going to invest. So, as the value of the currency falls, the more miners will flee, and then the security will decrease. So, this is kind of a cycle. So, in that sense, that all these three things kind of is must be in equilibrium in order for the Bitcoin to retain its value, retain its security of the ecosystem, and have enough miners to mine Bitcoin. So, that is the point that is discussed here. Now, one more thing is that we keep hearing in the news about 51% attack possibility. So, what can a 51% attack do? A 51% attack can actually do a lot of things, but not everything. For example, a 51% attacker cannot steal coins from an existing address, because that existing address might have coins, and it received the coins through some as output of a previous transaction, and only way to steal those coins is to know the private key of that addressee. If you do not know the private key, you can never redeem the coin. So, 51% attacker are not, it is cryptographically protected, it is not based on the consensus. The 51% attacker can only influence the consensus or how the blockchain develops, but it cannot subvert cryptography. Second thing is that can it suppress some transactions from the blockchain? Yes, because it can actually, if it has 51% power, it will start developing another chain. So, if this is the original chain where your transaction was there, and then it will start, and then you actually got 6 confirmations. So, you are now or got 5 confirmations, and you are waiting for one more confirmation before you can redeem. At that point, the 51% attacker can come and start building here another branch of the chain, and since he has more hash power, he keeps building more and more of these, and others also get fooled and start building on this, and this becomes longer. So, then your transaction becomes no longer part of the permanent record, and therefore, you cannot redeem that money. So, that is a possibility, and that possibility can also happen if you had 6 confirmations. If 51% attacker attains, let us say 90%, right. So, in that case, he can really build every 10 times 9 blocks will be built by him, and therefore, he can very quickly surpass even the 6 length long confirmation. So, that is a real possibility depending on how much above 51% he is, and even with 51% there is a probability that you will make more than half the blocks, and therefore, he can surpass the existing chain. But he cannot suppress a transaction when the transaction is being broadcast into the P2P network. That requires an attack on the P2P network by network cyber attack, rather than on the consensus process or on the block making or on the any other cryptographic technique. So, that he cannot do. Can he change the block reward? No, he cannot change the block reward, because block reward is part of the rule, and therefore, he even if you have 51%, you cannot make blocks which gives you more reward, because if you give yourself more reward, then others will not validate that block, and therefore, you will not be able to do this. Now, what he can do very well is to destroy the confidence in the Bitcoin ecosystem, and therefore, the value of the Bitcoin will fall, miners will flee, and the whole Bitcoin infrastructure will collapse. And that is what we were trying to actually say in the previous one, that all of these things should be in an equilibrium, so that the entire ecosystem does not collapse. The value collapses, the miners flee, and therefore, transactions cannot be put into the block securely, and things like that. So, the remaining questions that we will take up next in the next classes is that how do you get from consensus to currency. And so, because we discussed consensus and we discussed creation of currency, but eventually there has to be a mechanism, and how the way the consensus gives us currency, and that is called the Bitcoin mechanism, and we will be taking up Bitcoin mechanism as our next topic. And the other question is, what else can we do with consensus? And this is the question that will be pondering even after, when we talk about other blockchain systems, all of which will require some form of consensus. And so, we will look at what other consensus mechanisms are there. We, in some cases, we directly do a Byzantine fault tolerant consensus or randomized Byzantine fault tolerant consensus. Sometimes we do other techniques, but eventually we have to have some form of consensus in order for creating permanence and verifiability in a decentralized system. So, that is basically the end of this, and we will be actually talking about the Bitcoin mechanics, how the transactions look like, what are the different things that go into a transaction, and then how the transactions, how the blocks look like, and how the transactions are stored in the block, what kind of data structure it is stored in. Now, you might say that if we are not interested in cryptocurrency, why are we going to go into that much detail of Bitcoin mechanics? The reason is that many of these concepts that are being used there are actually pretty general, right. So, many of the Bitcoins, many of the blockchains actually use those same techniques. So, for example, the way the transactions are stored inside a block, it's called a Merkle tree. So, we discussed Merkle tree before. So, all the transactions are not stored like in an array or something, they are actually put into a Merkle tree. And we saw that the reason why we use Merkle tree is because the searching for a transaction is faster. So, that's one of the lesson from Bitcoin blockchain's block structure, is that if you have a lot of transactions, you might be better off putting them in a Merkle tree. And then we will see that in even later we will see that in Ethereum this Merkle tree has been further optimized. So, that is the one thing. The other thing that we will look into is that in a Bitcoin, you do not just put your signature and you do not just put your destination address, but you actually write some scripts, and those scripts are executed by everybody who wants to validate that transaction. And this script execution basically allows you to, and this script, how that script language, how much power that scripting language has, determines how many clever types of transactions you can do, right. So, we will see that there are many type of transactions other than just kind of transactions you have seen so far. For example, there are multi-sig transactions which allows you to jointly do something, and then multi-sig allows you to do further things like an escrow transaction, and then you can also do what is called micro payments. So, there are many different ways of doing transactions cleverly with the help of the scripting language, and that is called the Bitcoin scripting language. But we will see that with the Bitcoin scripting language, you have a very limited power, you can only do certain things, and that led people to think that why can't we write much cleverer transactions, and therefore, they started thinking about a new language for writing clever complex transactions, and that led to the idea of smart contracts. So, we will not get into smart contracts until we get into Ethereum, but smart contracts are basically pretty generic language compared to Bitcoin scripting language to write complex rules for transacting, and that means that we evolve from blockchain 1.0 to blockchain 2.0 as we introduce smart contracts. So, in order to understand smart contracts, we have to first look at Bitcoin scripting language and understand its inadequacy, which led to the smart contracts. That is another reason why we want to go into the Bitcoin mechanics in a more details, even though I am like totally opposed to the cryptocurrency, because unless we see what exists and what are its pitfalls, we cannot evolve to the next good thing. And that is another thing that we will study in the Bitcoin mechanics lectures. And after we are done with the Bitcoin mechanics lecture, we will move to the Ethereum, and we will look at smart contracts. But in this course, we will not be actually teaching you how to write new smart contracts. We will see some examples, we will get some ideas, but the point we try to put across to you is not to make you become a Bitcoin or Ethereum expert or programmer of smart contracts, but rather conceptually understand what the blockchains are, what their dynamics are, and how you can use blockchain for many applications. And after we are done with the smart contracts and in Ethereum context, we will move to a permission blockchain which is Hyperledger, and we will see how Hyperledger uses smart contracts and how Hyperledger does consensus. So, consensus in Ethereum is very similar to that of blockchain, Bitcoin blockchain, but consensus is Hyperledger is entirely different. So, because of that, we have to understand how the consensus is done in Hyperledger, and what are the other possibilities in Hyperledger to do the consensus. And interestingly, in Hyperledger, they have a pluggable consensus. So, you can write your own consensus and plug it into the Hyperledger. Hyperledger is an open source system, open source blockchain. So is Ethereum and Bitcoin as well. So, so then we'll see what are the other applications that people are using, and why are they not using one of these previous blockchains and developing their own. So, for that we will look at least one for specifically designed for IoT systems, and it is called IOTA, and then we will look at one for the financial players, and that is called CODA. And then if we have time, we will see a few other blockchains, and then we will look at least one or two applications like land record on a blockchain, or medical information on a blockchain, this kind of an application. So, at the end you should have a very good idea about the underlying theory of the blockchains, and then what are the different types of blockchain, the evolution of blockchain technology, and where it is applicable and how to apply them, and then eventually choosing which blockchain is your most applicable for your application, and whether blockchain is at all applicable for your application. So, this is the whole game plan here in the rest of the course. So we will see you next time with the Bitcoin mechanics.